For this video, we are going to define head loss. Now, in order to define head loss, I need you to reach back into your memory banks and think about the video where we derived the conservation of energy equation in its mechanical energy focus for a steady flow, one inlet, one exit device. If you can't recall, you can go back and look at that video, but I'll explain what you need here as well. So when we derived that, we took the first law of thermodynamics. We replaced the specific enthalpy with what it actually is, a specific internal energy plus pressure times specific volume. We replaced specific volume with its definition of 1 over density, and we rearranged everything, and we got to this equation you see here. Where on the left-hand side, everything's grouped throughout the entire equation in terms of head. Right? Everything's each grouping would give us some measure of height. So on the left-hand side, we have pressure head, velocity head, and elevation or head of the inlet. On the right-hand side, we have pressure head, velocity head, and head of the exit. Then we have the pump or turbine head, depending on what type of device is in the system. And we took everything else, we grouped it together, and we took the specific internal energy change and the rate of heat transfer from the inlet to exit, and we said, let's group this together, and we're just going to call that head loss. And now we're getting back to defining what head loss is, and we're going to show you in subsequent videos how to calculate that head loss. But to define head loss, let's go back to that derivation, what's in that red bracket. And as we talked about previously, we assume inviscid for a lot of calculations, but the reality is there's no such thing as an inviscid fluid. There are always viscous effects, and depending on the type of fluid, it will change the viscosity. Well, those viscous effects produce frictional heat transfer and an internal energy change of a flowing fluid, and that results in what we call head loss. Now, there's two different types of head loss that we'll be looking at. Major head loss, which are the viscous effects from the conduit wall. Think of the friction between the wall and the fluid. That's your major head loss. And then your minor head loss are losses that result from geometric variations. Now, don't be confused by the names. Sometimes there is more minor head loss than there is major head loss. It really depends on the length of the system. In a normal pipe system where there are fewer bends and it's more a long stretch of pipe, the major head loss is going to be the predominant factor, hence the name. But if we have a very complicated set of pipes and lots of bends, lots of curves, lots of valves, minor head loss will be significant as well. And so head loss is the sum of all the major head loss plus the sum of all the minor head loss. And in subsequent videos, we are going to define what each of those are and how to calculate each one of those.